Hi everyone, in this video I just want to share to you regarding my field work. So I have data from my drone. I use drone Mavic Pro 2. Maybe my lecturer or my expert team capture the imagery from the drones. They use Mavic 2 Pro as the tools, as the instruments, and maybe right time maybe I would like to analyze the results from the drones, and maybe because we did a field work in the 10th goals before. So right now I would like to analyze the data. So my objective from the field work was uh, to calculate the the ecosystem of the coral reef. So right here, maybe I'd like to analyze the, the coral reef extents that I can extract from the drone imagery that I captured, that my team captured in the Pandang Islands in Batubara Regency in North Sumatra Province. So I use a random forest as a models. I use a machine learning especially, and then after that I have the imagery from the drone. Maybe I'd like to um, analyze with random forest, and then the trainings data from I got from my fieldwork, and then I just try to combine all of this, and then I will get the results like a coral reef extents. So um, the first you have to maybe all of this I would like to um, make this all the code off, and then we just focus on the center object, and we just want to call the drones. So if you want to put this true, so when you run the code, the imagery will open in on this section, and then you can see the imagery directly in on your screen like this. So I just want to write the code false, because I want to I want to check the columns in this area when I will run this code. So maybe right here I will run to I would like to run this code, and then you can see this is my drone data. I think this is the specific data, and the imagery is clear without any cloud on the top of the islands. Maybe this very clear data that captured, that my expert team captured on the field work before. So in this area, so uh, we also collected all of the training data for this analysis. So because we want to use this data, we would like to use this data using random forest. So I think when we were in the field work, we focused to collect the all the field training data like this. Okay, after that, this is several function that we need uh, to manipulate, or maybe to increase um, the ability of the random forest to classify to make the segmentation, maybe I mean of the coral, sand, other substrate, and the vegetation. So because we only have the RGB data, especially red, green, blue, this is the true color, because we just had drone Mavic Pro, that we know that the drone's results only um, create RGB for the lens of the drone. So this is the limitation of our instrument. So uh, due to the limitation, we can make the modification of the image, so we can get the result, the the high quality results from this image, because we our objective is the coral reef extent. So the first, I would like to define the NDVI. So the NDVI also to omit the water columns, the deep water columns, and then maybe we just need the data uh, that the human eye can see. Uh, the coral reef uh, in the top of the reef maybe. So like this, we just only want to analyze the coral reef in this area, in this area like this. So we don't need this deep water, so we have to omit all of this deep water in the area using the NDVI as the marks. So this is the marks of the NDVI, and this is the NDVI. This is the several there that are several index that we need to um, increase the models, so the models can analyze the coral reef extent that the human eye can see. Okay. After that, maybe so because this limitation, we just have a three index. So if we use like a sentinel or landsat data, we can also explore all the band, and then we can get the high the several band, and then we can also use the several band as the function as an index, so we can get the high resolution data. However, in this analysis, we just have RGB, and we don't need the uh, commonly, when we want to analyze the coral reefs, we need the water correction using the Lizinga method. So because we just only have RGB, we don't need that. But I think this is the limitation. Maybe it's okay if you don't have any band like that. So I just want to use this without water correction. This is the next, and then the image. So you have to apply all this function on your image, and then you can call the image like this. And after, if you want to print, up to you, you can print the data. You can see the properties of data, and then it is the training sample data. So I use band 1, band 2, band 3, NDVI, and also red as because I use normalized difference between B1 and B2, and then the fixed data. So I define the name of the fixed data with merge, and you can call the merge data, right? And if I all those all the data, all the everything in all of this in image that you create the function before. And then this is for the training data places like this. You can see, forget to put like this proper type value. You can use the feature collection as the MPAs like this, and then you can modify the name. That's because the name I use the TK as the name, and for the coral, and NTK for the non-coral. So the vegetation, the other substrate, and also the rock, I use the rubber, I use this non coral and NTK name for the format. And don't forget to put the properties for the collection like this, and all this code for the random forest models. So this is for the checking the models with the 80% of the uh, training, and testing for the 20%. And you can search all of these method in the database of the Google engine. So they provide all of the code, like random forest, small random forest, or small chart like that on their database. So this is easy. You can search everything in the Google engine database. You can get the code in there as your models maybe. So I use random forest, small random forest in on this code. And I also uh, write the code for the validation and test accuracy in the in on the uh, code. And this the last is for the export the image. So the image results uh, should would be will put in will the export will the data will be exported to your drive, Google Drive. This is the ROI, the region of interest, like this, A. And so if you don't want to export, you can erase, or you can omit all this code like the export. So if you want to export, so you can write a code like this, and the data will be exported to your drive. Okay, maybe automatically. Okay, okay, like this. Okay, we see the results of the data. Okay, okay, maybe it takes minutes for the analysis using the random forest. Okay, okay, this is the data. See, so I omit all of the deep water in the area using the NDVI as the max, and this is the coral or extents area. So wait until the analysis has done. Okay, this is the results, the final results that we can see on my screen. So the green pixels illustrate that the coral reef indications. Maybe I would like to say that indications or yes, prediction maybe, yeah. So this is the prediction of the coral reef on my screen like this. So we can check the results from the models. So we can see the validation in here. So we got the validation of our calculations in 80% up to 80%. So this is the good results maybe, and you can check directly on the coral reef extent in here. So we can check like this. We just zoom in to the several to the specific um, image, specific location on my image. So it takes a minute maybe. Okay, maybe it takes a minute. So I would like to uh, omit check uh, off the image in the data image. So like this. So based on my field experience, this area is uh, indicate indicated was indicated a coral reef, but we don't know the we don't know the quality of the coral reef, but this is the coral area. So this is the indication of the coral area from my field work. So my team, my expert diver team, uh, collect the several fieldwork training data when I was in the field. So I just used the field coordinate to training data. So this area indicate the curve. There are coral reef in there, but I don't know the quality of the coral reef. The if whether the live coral or the dead coral in there, or the coral with the alga. So I don't know. I don't know the specific uh, conditions of the coral in the area. So uh, I think this is enough for me to tell you about my experience. So I think this is not. I think I want to say that this is not the accurate. This is not the high accuracy data maybe, because I just manipulate with the index, and then I just directly put the random forest models to analyze this image. I think this is not the accurate. There is not the one model that very accurate for the for analyzing the coral reef, but we have the unit. If you know about the Google Colab, the package the unit package in there, using TensorFlow, using deep learnings, any deep learnings methods, maybe it more accurate. It better than you use this and then forest, because deep learning um, is the next. uh, I think deep learning is very powerful to create to analyze the pattern of the pixels maybe. You can use deep learning unit maybe. I know unit because of uh, due to the limitation of the training sample. So I um, I consider to use random forest for this analysis, for this field work. Then I use deep learning as using unit model TensorFlow, because I don't have any training image. So I prefer to use this random forest. But if you want to get more accurate data, you can use the deep learning or any deep learning method. So I recommend it to use unit GOAI. I think that's more accurate than this. Okay, thank you. I think that's enough for me. Thank you for watching. Look on.